Okay, before I go to the carbon trap and individual actions, I decided to add this table. I have an entire course or series of podcasts based on this book called Drawdown by Paul Hawken. And there is a project called Drawdown which works on solutions and also lists a very nice things that as coming attractions in terms of how things will look in the future in terms of food, buildings, transportation, energy, health, and so on and so forth. So let's just look at this briefly. The book also does calculations of the net cost in implementing these transitions, let's say, or solutions, and estimates the savings resulting from these from implementing these solutions. Of course, such economic calculations can have many assumptions and hence many uncertainties, but at least the list of solutions is very sensible and very useful and should be implemented. It's not something that will have unintended consequences in most cases. Okay, so refrigerant management, it's in the sector so the book is split into various sectors: materials, electricity generation, food, land use, women and girls, electricity generation again, and so on. And it also computes the potential reduction in CO2 equivalent. We already mentioned refrigerant management. HFCs are a massive greenhouse gases, and there is unintended leaks and end-of-life emissions that are completely avoidable. But we know that CFCs were banned, and as we mentioned before, it was an easy decision because everybody was going to get hurt by the ozone hole, whereas HFCs, which were readily available to replace CFCs, turned out to be somewhat of a Frankenstein experiment because we didn't know they were so much more potential greenhouse gas warmers. So refrigerant management itself has the potential for reducing CO2 equivalent of 89.74. Again, CO2 equivalent is when we take a material like HFCs, gases like HFCs, and convert them into CO2 equivalent using global warming potential that we mentioned before. Maybe I'll include a global warming potential table next time, okay? Or you can find it on Google, of course. Net cost to implement is not applicable because already there is necessary rules and regulations and requirements to do this, but doing it properly would save 902.77 billion US dollars. Negatives are when there is no cost and there is a net profit, you would say, because there is a net saving where if you did B it would cost so much, if you did A it would only cost so much, so the difference would be a net saving. Here you are actually making money by managing this properly. Wind turbines onshore can reduce 84.6 gigatons by 2050. By these numbers are by 2050. Net cost would be $1,225 billion, but net savings would be $7,425 billion in terms of what these wind turbines would replace in terms of fossil fuel burning and emissions. Reduced food waste. We talked about how 6% of the waste of the emissions from agricultural sector is coming from waste. There you could reduce over 70 billion tons, gigatons of CO2 equivalent. There is no cost involved in reducing waste, and it also doesn't have any savings as such, but emission savings is of course a big payoff, co-benefit. Plant-rich diet, we talked about reducing meat consumption, 66.11 gigatons. Again, there is no net cost to implement, and savings obviously also not in terms of monetary value, but in terms of reduced emissions. Switching from meat to plant-rich diet is could be cultural, could be nutritional requirements, whether you get proteins from fish or meat, or whether meat is a big part of your tradition, or there are people who hunt whales even though whales need to be protected, and so on. But there are also ways to transition based on other options, I suppose. Tropical forests that we talked about can save 61.23 gigatons of CO2 equivalent. No cost involved, hence no savings involved either. Educating girls has all sorts of implications on lifestyles, consumption, and other emissions. You can look up the total impacts, but we know that educating girls results in reduced fertility rates, reduced population growth rates, which is already happening even in countries like China and India, as we mentioned. Estimated reduction in CO2 equivalent there is 59.6 gigatons. Family planning, where you make choices available for managing the family size. Even though educating girls turns out to be one of the best contraceptives, there are still issues of family planning being made available to women who are not financially independent and can be not having enough power to do the choices on their own, make the choices on their own. So that also would save 59.60 gigatons in CO2 equivalent, and no financial costs and benefits associated with that. Solar farms, of course, seems very intuitive, but if we did it right globally, we would save 36.90 gigatons of CO2 equivalent. Implementing it actually would be net negative in terms of net cost, and net benefit would be over $5,000 billion. So you're getting in the range of trillions of dollars. There are caveats there, of course. We haven't done the life cycle analysis of solar cells, so what happens to solar cells at the end of their life cycle, the materials needed to produce them, recycling them, discarding them, and so on and so forth, have some issues to deal with, but nonetheless solar energy is infinite and available forever and can be used intelligently to take care of all the caveats as well, right? Silvopasture is where you are combining grasslands and other food systems to manage grazing, cattle, meat production, food production, and so on, with potential reduction in CO2 equivalent of 31.19 gigatons, would cost $41.59 billion. If you don't know how the calculations are done, don't worry, the book provides details on all the assumptions that go into making these estimates, but just get a sense of magnitude of what are the costs and what are the benefits. So $699.37 billion US dollars in net savings after you invest $41.59 billion to implement silvopasture as a method. Rooftop solar. So this is utility scale solar farms. These are rooftop solars. Atmospheric CO2 reduced there is 24.6 gigatons of CO2 equivalent. Globally, using the potential for rooftop solar, the net cost would be $453.14 billion, and the net savings would be $3,457.63 billion. dollars. So these are not trivial numbers. The book lists a long list of such solutions, as I said, with a last section on coming attractions, which is also good to look at. And as I said, I have this entire book converted to podcasts on my channel as well, so you can just listen through that if you don't want to read the book, because I also add a lot of additional details from what is listed in the book. Okay, the book is rather succinct in each topic and lists net cost, net CO2 saving, and net benefits. I add lots of caveats and other details in my podcasts. Okay.